We are digging into plant biology at the Salk Institute. They're known globally for all the research that happens here, and fortunately for us, it's a local treasure. I'm Ashley Jacobs, and this is the LOCAList SD. The Salk Institute is known equally for the beautiful architecture and incredible research that happens here, but you may be surprised to know about the incredible plant biology that's happening here. We are giving a behind-the-scenes look at the Ideal Plant program.
In 2017, a number of Salk scientists came together who were all working on plant biology. And we decided to start thinking about how we can use plants to address the climate crisis. Plants are the world record holders in catching CO2 out of the atmosphere and putting it somewhere else. In their plant bodies, we know that as wood in the forests, or transfer it into the soil, where the best soils have a lot of carbon. And the carbon that's good for the soils is the carbon that's bad for climate change. And in order to do so, we need to understand the genes and the mechanisms in the cells of these plants, how they can do this right now and how we can make them better. And so for this, we have to look at the genes of the plant. So we take plants, we grind them up, and we isolate the DNA and the genes, and we look at the genes and see what are the genes in plants that are already better in doing this, and how can we make it better. One example for changes that we can make to plants is a gene that has a very complicated name. It's called the Exosys 70A3. And it helps to grow root systems of the plant deeper. And then we looked at plants that had this tendency and plants that didn't have the tendency and wanted to know what's different between those. And that's how we found this gene where a plant that has a more shallow root system had one version of the gene, and a plant that had a deeper root system had another version of the gene. Those are root cells, and those are root branches from the main root. And one can see a molecule that is one of our molecules that we want to make more of to store more carbon for longer. That is here stained by this yellow stain. So in these cells, there's much more of this molecule.
There are 4 large chambers and more than 20 small chambers, each extremely well controlled.
These chambers are really key for us to find genes that we can harness and utilize to make plants better, to store more carbon for longer in the soil. And in order to do this, we actually grow hundreds, perhaps thousands of different plant varieties, and we record how do the roots grow. These are very highly controlled chambers. And so, for instance, this chamber here, we are simulating a temperature of early summer.
Oh, wow.
Yeah, those are our favorite plants, Arabidopsis thaliana. And we know everything about these plants. We know their genes, we know how they work, how the cells work. And so we are using these to explore the genes that can lead to more roots and deeper roots, and hopefully can be transferred to the large crops to mitigate climate change. This, for instance, is a system where we can look at the roots. You can see that here, and that's a soybean plant. Okay. And we test here whether the root system of the soybean plants that we can see here can go into a hard subsurface, because often in the field the soil gets very hard. So if we want the plants to grow deep, we need to understand the genes that enable plants like this to basically penetrate into a hard layer, which you can see here. The large goal of our initiative is to make what we find available to the world to put it in as many plants as possible. So we are actively working to be able to transfer what we learn here in the lab to the world, so that hopefully, by the end of this decade or in the next decade, that can start to make some impact, and then hopefully in 15 to 20 years can make a very large impact.